Hi, Renato. I can't hear you. I think you're muted.
Right. I have no idea, but I tend to forget it. Okay.
Okay, good. Okay, very good. Yeah, good.
How are you?
Not bad. Sunny day, so I don't care. So here's a couple of slides we will go through today, okay?
Mm-hmm.
And also we'll jump through your slides. So these are the screenshots from Vegas, you know. So
Yeah, okay.
So yeah, so but
them.
these are some like some screenshots you cannot find on internet, you know. So they have some real value.
And yeah, because as well, I saw that the presentation as well is not, some of the slides are not there. I don't know how they did it, but I don't know. It's just weird. Anyway.
Yeah, we'll see. We'll see. Okay. So Renato, like I'll give you a couple of minutes to introduce yourself, and then we'll just we'll open a free discussion, you know, and don't worry. So.
Okay.
Maybe we can share the link to your reInvent session.
Nice,
yes.
Thank you.
Yes, it's good. Let's do that.
I was really hoping that they were putting up the one from reInvent. I asked last week again. I was like, oh, we cannot find it. It's like,
yeah, okay. Yeah. That's strange. That's really strange.
Anyway. But yeah, it was an interesting week as well, seeing all the announcement and all the changes. I didn't expect it to. It was pretty obvious that the first summit in San Francisco was a good occasion, but I entirely forgot about that. I didn't consider it could happen last week.
I mean, look, they promised it's going to happen like a year ago, so.
Oh well.
Okay. So Renato, I mean, we had a chance to talk a lot in last reInvent, and I really enjoyed your company there, and we had some really good time discussing about when is this thing going to be released. So this is one of the things that was like waited most. Like I don't really understand why what is going on with AWS. Are they going to like take 2 years from the next preview to some final release next time? So this is not a really good sign, you know. Like they promised something and then 1 year and a half we were waiting, you know. So how do you feel about that?
Yeah, that's an interesting topic. I mean, I was as well really optimistic when I did a presentation reInvent about Serverless V2 that by that time was not a preview. So I was hoping, as everyone else, that was at least less than 1 year. My feeling is is mixed. In one sense, I think few things went wrong and few things changed, because as well, the preview as well is not just that it was 1.5 year in preview. For example, was 1.5 year in preview without many features and without Postgres, for example. So, and as well, MySQL was a 5.7 in the preview. So many pieces were actually very different in the preview, what they announced 1.5 years ago versus what really came.
But do you see like AWS has enough capacity to deliver when they promise something? Is it is it happening now? Are we like in trouble?
No, I don't know. From my point of view, maybe I'm too optimistic, but as well, I think this one more as a one-off than. I mean, of course, it's quite worrying that it took 1.5 years, but as well, it's quite weird as well to have a V1 and V2, and we even discuss about that when we joke about the V3. But most of the other things are not V1, V2, are iterative. That's something new. So
Renato,
I saw some other ones that came out of the serverless. That I think now I'm missing some of them, but some of the serverless databases that they announced as preview at the latest reInvent are already GA now, that they announced last week as well. So, or as well, even SageMaker, for example. So the serverless part was, so I think was more a one-off, the
Yeah. Okay. But this is really hard thing to do.
Yeah.
So like vertical scaling. Yeah. I prefer calling it vertical scaling and not really serverless. So yeah. Just Renato. Thanks for joining me, and give me some like. Give us some intro about you, and you are my fellow AWS data hero, but also, I mean, you're doing a lot of other things. So please just give us like, you have 60 seconds.
Well, I probably need much less. I'm been working with AWS technology for over 10 years now. I'm, as a background, a developer coming through kind of typical cloud architect that is a bit lazy, doesn't want to manage himself all the production relation database, because as you say, there are complex things and challenging things, as we say as well, with 18 months to get the GA. So I tend to I got really interested early on in managed services, whatever was Aurora, AWS, serverless version, all of them. And I enjoy using them to do, well, what you call vertical scaling or serverless, or whatever you want to call it. Any way to have an elastic capacity in the data layer. Yes.
You also write for InfoQ, and you have nice, interesting stuff.
Yes, I'm an editor for InfoQ, where I cover cloud topic. I try to write a couple of pieces a week. I see more as well as a way to not just think about AWS, because one of the problems when you're so involved with AWS technology, you hardly see what's happening around. So I see it as well as a way to, a bit as I saw in the past certification as a way to test things that I never forced myself to at least open the book and the documentation. Things I've never done. I see as well InfoQ as a way to kind of know what Google is doing, what Azure is doing, or whatever they are doing, 400B or whatever.
You're out of your 60 seconds, so now let's go to Serverless V2. Okay. So today we're gonna talk about Serverless Aurora V2, and for everyone who's coming to this meetup without any previous knowledge, it's not easy to jump in with all these terms. So yeah, let's give a couple of words of like a short intro on what is this all about. So first of all, you can run databases on your own servers. You can run your database on AWS server. You can install it there and manage it by yourself. Then you can use some kind of managed service called RDS. The first step of RDS is you can install your server, but just clicking on a button or via some infrastructure as a cloud as a code stuff. And then at the top of these offerings for relational databases in AWS, there is something called Aurora. Okay, so Aurora is offered only in the MySQL and Postgre versions. And what was so revolutionary with Aurora is it was that it's just replaced the storage layer of these databases and provided us with some servers that allowed us to completely ignore the fact that it's installed somewhere, and this cloud capacity for storage allowed us to scale infinitely in terms of storage, and also to get like some really good numbers, really a lot of nines. So we are really sure that something that we save somewhere, it's there. Okay, so Aurora storage, it's not just hard disks. It's a lot of servers receiving messages from MySQL or Postgre, and please save this number, save this, and these servers provide us with like a insurance that they insure us that it's going to be like super secure. Okay, and also what Aurora provided, it's also a global layer now, so you can write something in one region and then you can have this data in another region. Okay, so the great thing is that it's managed by itself, so we have this super crazy storage layer, but on the other side, it's also more expensive than if you do it by yourself. So for everyone coming into this game, you have to understand why are you paying this, because it is more expensive, but then you don't really have to think that much about what's going on. So And now this serverless V2 it's a new offering, providing us promising us some even higher level of managing these servers by itself. So it's scaling, it's vertical scaling in a simple way. So it was like reinvent to 2020 when AWS announced it, and it's 18 months now from that date, and now we have GA. So during the last year, we had a chance to try something called preview, but it was just like an option where you can install one server, and you were not able to mix it with other servers, so you couldn't use it in real production stuff. So it was really hard to test the how good it is. And now we can really try it. So a couple of years ago, Amazon provided us with something called Serverless V1, and V1 was a serverless offering. Okay, that's how I feel about it. It's completely marketing. Okay, so but it had something that many people thought, oh, okay, this is going to like develop to be a really serverless architecture, and but it failed. Serverless V1 failed, and why do you feel? Do you feel the same like Renato? And
well, if you see it as the serverless version of Aurora, it definitely failed because it had just a subset of feature of Aurora, and that was one of the main problems. And as well, it was elastic, that was good enough. You had something elastic in the sense that there was a minimum of elasticity, but it was basically replicating what you could do yourself. Not as good as you could do it, doing better than what you could do yourself to change the instance type, but you were still doubling the instance, doubling the capacity every time. So the scaling was doubling. It was taking seconds. Seconds is not bad. It doesn't sound that bad, but it's not that great. So yeah, in that sense, it failed because it didn't have multi-Z. It didn't. So if you were planning, there are use cases where V1 is great. But if you are thinking to use Aurora, and then, instead of using Aurora, let's call it traditional, I want to use the serverless one, you had to give up a lot. So
and it didn't scale well. I mean, did you have a chance to use it in some real production?
No, it was
workload?
A small environment.
Yeah, small environments, mostly development, staging, and stuff like that. And why is it so hard for serverless V1 to scale? So people may think that it's just serverless and it should just scale automatically. But there is no magic. There's only servers there. So the problem was that in V1, if we wanted to scale up vertically, it means like you have Aurora storage, which is on below everything, and then you have a problem with CPU and memory. So you have to scale up. Okay, so you want more CPU and more memory, and then you ask your server, okay, I want this query to run. Can I just jump up? And the server says, okay, I cannot scale anymore. I'll prepare another server with the double capacity from this one. And please wait for me till I get ready. And then there were some smart things there. They were just copying memory buffer. For example, if you are scaling up, it was like the copy was hot. So your data was there. So these things, during this scaling, you don't lose data, so you don't have to go back to disk again. So it was smart, but it couldn't scale every time. So sometimes it can scale, sometimes it can't. Sometimes it can't scale even down. So how do you feel about that? Like, why do you feel term serverless is misused in terms of V1?
I don't know. I mean, the thing. I mean, I will call it an endpoint without a capacity. that basically you have a range of capacity. So you have a CNAME, and what happens is basically a layer of abstraction on top of Aurora. But yes, of course. But I wouldn't call it. Then it really depends what you mean by serverless, because I mean there are different definitions of serverless. If you stick to the definition that, for example, you say capacity, you shouldn't pay if you don't use it. Capacity should go to 0. We'll come to that, I guess, in a second.
Yes.
Probably V1 was closer to that definition than V2, because V1 actually you could set that was going to 0. Going to 0 was great for development, staging, whatever environment where you didn't need them, but it was pretty hard for any production one. So I don't know if it's misused. Probably it's misused in most cases, in anything that is not a function.
Yeah. So there were some good things in terms of when we talk about serverless, moving relational databases to serverless. There were some good things there, like you didn't have to provision server inside of VPC to get servers. So your Lambdas, I mean, there were problems with Lambdas, especially with when they were using VPC. So it took some more time to connect
Absolutely.
to your database. But now these problems don't exist anymore. So it's just about thinking about VPC, and then more, and it was more costs. Okay, but then serverless V1 came with something called Data API, which is an option to get data or insert data into database, but just providing JSON or and connecting through a HTTP API. Okay, so that was one of the things that that many people were feeling like, okay, this is serverless. We can connect to it via HTTP. So anything that is accessible via HTTP, it's I don't know.
It's a managed service. That's an advantage as well. Yeah.
So there were many things that the people felt like, okay, this is it. We are going to have we'll have something like something smart here, so that will scale with us. But still, it failed in many ways. That it was not really something that you could use in production. You couldn't mix. You could have like more readers. You could only have one server.
You could not have read replica. You could have nothing really.
In terms of security, like I mean, in the reliability of data, it didn't even run in a multi-AZ environment. It was just one instance. So it just doesn't work for production workload. So so we were kind of surprised when AWS said, okay, now we have V2, and the V2 is gonna improve what? V1 or regular Aurora. So what happened? Like they actually created something which will improve regular Aurora more than serverless Aurora, and then they called it serverless. Okay, so they actually provided us with some things that were needed in provisioned Aurora more than they actually listened to someone who was on the serverless side. I would say, and when you look at the complaints coming from serverless community, there is no data API, there is no scale to 0 and stuff like that. These things are maybe not really something that is something that people coming from relational databases that they use them more often. They don't really think about that much.
I mean, if you think about Aurora the old way, a production enterprise database with a beautiful storage layer, what you were missing was elasticity. What V2 is trying to give you is that elasticity. Do you need going to 0? Well, it would be nice, but most production database don't need it. Is for many production scenario, you don't give a damn if it's 0.5 or 0 or close to it, as long as it scales down quickly and scales up quickly. And as well, data API, it would be nice, but you didn't have them on Aurora, so probably you don't need them tomorrow morning on Aurora Serverless V2.
And you can always build your own. You can always build your own layer.
Yeah, but if you are coming from V1, probably you suffer those things because you were used to have them, and you consider that as part of the serverless concept.
Yeah, I mean, also the possibility to define, for example, a single table and deploy it somewhere, like through using like a CloudFormation or CDK or stuff like that. So these things are not really natural in using relational databases in AWS. For example, you cannot even define a construction of servers in a cluster using CloudFormation. For example, endpoints or like these things are not really available. So you cannot define, oh, I want one instance of this type and one instance of this type, and then I want this one to be accessible through this endpoint. No, you have to do these things through API. So there's a lot of work to do in terms of bringing serverless closer to relational databases. Anyway, so why do you think that they brought us V2? Why is it like? What do you feel like? What are the first things that come to your mind? Like, why would they do that? Like,
you mean
V2? Like, what was the reason? What was the main motivation that they said, "Oh, we need this"? Is it coming from provision community or serverless community?
I think more from the provision community. Yeah. I mean, the feeling I have is this one is going to cover more the having a database that is much more elastic. So before I had to decide myself if I wanted a 2 extra large, 4 extra large, 16x, whatever instance, if I want a M6, C4, whatever I'm using, and think about it. Now you can think, well, I want basically, as I don't have to define the storage layer, as I don't have any more to say, oh, do I need to start the database with 400 gigabyte of storage of 2 terabyte or whatever that I have to pre-provision and pay in advance? You have the same feeling about the memory. I mean, I have no clue how much my database needs in the first few days. I don't want to keep changing it myself. I mean, I can do it. I can create some nice Lambda function that according to number of open connection, number of CPU, load, whatever, does some scale up and down, but there's downtime. There's a lot of logic around that. You're still doubling and scaling down. I mean, there's not many steps. If you think even about V1, when you say I can go from 1 to 256, yes, it's true. I think it's 256 still.
Yeah, but it takes for MySQL, for
Postgres,
it's a bit
500. Yeah, but it's basically 1, 2, 4, 8, 16, 32, 64, 128. I mean, it's not.
And it takes time.
It takes time. And it takes time.
But
and it's a few
can I show you the last slide for this presentation? So that thing that you just said, oh, I don't want to think about that, will cost you with V2 much more. Like, this is the difference between provisioned and the serverless V2 for the capacity of 64 gigs. You know, is it worth it? Is it worth it?
I have two feelings. Number one is I don't like when people compare. It's not your case, but one of the standard comment I always said with V1 and as well with the first slides of V2 was, oh, well, if you need to run it at 0.5 as a minimum, a micro instance is going to cost less or whatever, or a small instance or whatever. I think you are missing the point. I mean, yes, it's true, but as I said before, I'm lazy. I want to go away on the weekend and know if the traffic goes up, the database scales up. I don't want, if I have a micro instance, a small instance running with 1 gigabyte, 2 gigabyte of RAM, I know that it might work. It's not multi-Z, it's not nothing. I might have a multi-Z one, but it might still not scale.
Okay, sorry. Yes.
And on the other side, your number, I tend to agree, but I cannot think of any production database that I have where my average CPU on the last, in a long period, not in a couple of hours, but in a 24 hours period, in a 1 week period, the average is 80% or 90%. So it's likely in the even doing some scale up and down in the night or whatever, I still have an average in the 24 hours that is more close to.
So if you look at this chart, you see this chart? Okay, so
yes, the active session, yes.
Yeah. So this is like production workload in one of the servers. So all this white area is something that you pay because you don't use it. Okay.
Yes, because so basically that's estimate there's a virtual CPU that you had for that machine, probably you had 8.
So even if we scale it 4 times, we may be good.
Yes.
So serverless V2 may have like there could be some mathematics in that. Why is it so good? Why is it good? And what can it be used for? So yeah, let's see some of the things that they say about how it works. Okay, and see
if it's true.
So let's see. They say that they can scale up and down in a couple of seconds. And they say that they have enough CPU capacity and memory capacity. So when I have a query and they say, oh, we don't have capacity on this CPU or memory or network, so one of these 3 parameters, we'll just give you another CPU. And then we'll route your query through that CPU and it will execute and get back results. So the problem is like, we need to understand what's going on. What is it that takes one query to execute? It takes some time to get data from disk. And then when you get data from disk, you need to, if you're doing some joins or you have to pack that data and get back to the client. So if it's a huge query, a lot of data, then it takes more time and then you need more CPU. So CPU is there just to combine data, okay? But you still need memory to get, when you get data from disk, then you pack it in memory. So they say they can give us new CPUs and new memory just like that, okay? And they promise that we can scale up and down in some increments they call ACUs.
Yes.
And ACU is something that has an equivalent of 2 gigabytes of RAM and 1 CPU. And 1 CPU means like 1 CPU for that period of time. Okay, so they can give you less or more time for the same.
I actually
CPU.
think that maybe they kept it because it was the same definition in the V1, but I find personally very confusing the idea that the minimum unit is 0.5, that is actually equivalent to 1 gigabyte. So
It is.
You could have probably a different unit, but I guess it's to keep it consistent with what was in the V1. Otherwise, I don't know what the reason is for the 0.5 increment and for the 2 gigabytes.
So how they managed to get this to technologically, and like they first had to switch to ARM technology. So otherwise they wouldn't be able to provide enough CPUs. And the other thing is capability of MySQL and now Postgre to scale buffers, memory buffers. Mm-hmm. And I was not aware that like Postgre had this capability, and I thought it was just MySQL. But at the end, the shared buffers also in Postgre are there. So you can scale online your buffer of memory, and it's easy when you do that like online. In one server, and going up. And the thing that they have ARM, and they have like they have very smart capacity planning and management, gave us this option to have serverless V2. So the thing that was like the most important thing here is that thing about buffer pool resizing. And one of the slides from reInvent last year was about that, like how they manage the buffer pool. So the buffer pool is there to provide us like high speed of management of data, so we don't have to deal with disk. Okay, so once you get your data in your buffer pool, you can do something with that data. And if you have more queries, if you have more memory, you can accumulate more data. Okay, when you don't use the server, they say they will just evict some data, remove data with some smart techniques on when the data is last used or last frequently used and stuff like that. So this is kind of technologically cool, okay?
Yeah.
But this could make a lot of problems. And one of the things that I've noticed in their documentation is that they are talking about you have to be that you have to be very smart when you define the minimum ACU for your server. So if you put it too small, you will just lose your buffer pool. So whenever you have a new query about for the same data, you have to go to disk and then fill the memory again to go to disk and fill the memory.
But I mean, that might be not obvious, but if you think the other way around, you basically, you cannot have it both ways. Either you say, I want it, what you call serverless, that basically, if I'm not doing a query, if I'm doing nothing, I don't want to pay, I don't want to have anything there, ideally. But if I call it again in half a second or in 200 milliseconds, and I want to do the same query, I want that is in the buffer pool. So either I keep something there, so I keep a minimum capacity because I know, yeah, my database spikes. So it's more like a way to say, I have a minimum baseline, and then I have some elasticity. Or I say, well, I give up the entire buffer pool every time, but then is my problem. I mean,
but they could scale separately, CPU and memory. So
yes,
the memory can stay high and the CPU can go up and down. And so the problem is that the biggest problem is memory, you know, so that's something that would slow down the whole thing. So, but so far so good. I mean, if I when I look at the charts that I just showed to you, these are this is the metric from one of the servers running in
that's a
live.
302 serverless, okay.
Okay, let me show you the CloudWatch now. Sorry. So here the server, I mean, if you compare these two images, like the push of queries coming to the server and the chart that I see here, the first one showing the serverless database capacity going up to maximum of 32 ACUs,
yes,
and then going down almost to like 6-7 ACUs. That's like that's a white noise, you know. You cannot go below 7. I just tried a lot with my server, you know. So there's always something going on, you know. So that's the biggest problem.
Okay, yeah.
There's always like a small query doing something. Just give me a user data or something, and then you get dirty, and then your server never sleeps. That's the biggest problem. So this is something that's in production, that's real. Okay, so maybe you can show us the game that you played with the preview, and that's actually a very, very good example on how this thing scales, because now you have to compare these two charts that I gave to you, like, and see, well, this is actually it, you know, this is it. Number of queries mapped to a CPU usage. It's pretty close. Okay, we have to just match the time and stuff like that. But what you did, that proves how things.
A couple
really
of notes here is first one that I really think that when we talk about V2, I think Amazon is really pushing for it. One thing that really surprised me, I don't know if it was just me or whatever, but is now when you create a new serverless database, it's basically the default for Aurora. If you create an Aurora database and you say MySQL, whatever, he offers you the serverless option there as the first default option for your capacity. That I find it quite impressive as a thing for a multi-AZ cluster that is there already as the, even if it's just a default in the console. That's what. That's cool. Quite. And the second one is, I have the feeling from the first test that I did after it went GA is that the approach now is a bit more like more aggressive in the scaling up of the capacity, their side, and much more softer in the scaling down. I still don't have enough data to prove it, but it's like, and that probably makes quite a lot of sense as well. But it's,
of course.
But
you can share, you can share the screen now.
This, yes. Let's see if I can. That's the wait. It's always hard to find that. is probably this one, this one. Yeah. Do you actually see it right now? And I
yes.
send it now.
We don't have to go through like the whole story.
I'm going. Yeah, it's just I'm going to basically. Let's see that the idea of of course, when he loads, it never loads in the same way. Was basically I started to do with play a bit around with a simple test that I had on the V1 still. That was basically, I didn't want to do any proper real test. I just played and throw some data to the serverless version in V1 and see how the capacity, just inserting data, I didn't have anything to query. I just do some randomic value, throw them in, and I saw only how the capacity, and as we say before, the ACU, it just goes to 4, it goes to 8, and then it goes down. So there was no much mapping between the V1 and V2. What we did with the V2, we basically saw what you have just shown, that is doing the very same kind of test. You see that capacity and ECU more or less go hand in hand, much more closer. There's some noise. The preview had a minimum capacity of 4, so you couldn't really go to 0. So you didn't have much of that noise. I mean, you had a minimum anyway, so it didn't make much of a difference. So I then try something simple. I decide, well, if I can create some input that way, I can simply create any peak that I want, simply going for 1 minute, and instead of writing data for the entire minute, I can sleep for a few seconds. So the average of the minute, I could basically draw whatever I wanted. That was the ECU. So basically, that was just to prove the capacity of my database could go up and up with the. So then I simply play with just I just try to draw something like the.
But that was like that was a great example of how the server listens to your requests.
Yes, so the idea was to prove that, that it doesn't matter if it's millisecond or 1 second, whatever, but was that to show that what you're trying to achieve is that to have a server that reacts to you and it doesn't react in minutes.
That's the best thing, you know. So in my example, that was a production example. A real one. The real one. There is a lot of noise in lower levels. Okay, so I just can't scale back to 0.5. So the first advice that I can give to anyone who wants to start using Serverless V2 is to separate the workload. So in an existing cluster where you have one writer, add different readers. So you can have one reader for reporting service. Or like if you have some noisy tenants, maybe just separate them to specific serverless instances. Okay, so then you will have like a really clean picture of like this instance is just doing this job. This instance is just doing this job. So you will there will be situations where there will be zero traffic. You know, so that's something that you should try to achieve. And if you have things which are super clean, then these things can really scale to almost zero. Okay, so the good thing, like that was not possible with V1, and it's possible with V2, is to add one serverless instance to an existing cluster of standard provisioned capacity Aurora servers. What is the problem with tenants is that you can only have like 15 read replicas here, okay? But you can always make do some extra create an extra cluster and then do some binary replication and then extend it. You can have like 15, then 15, then 15 if you want to really play with that.
It's already 15 compared to having known before is already quite a big step for the server.
Yeah. I mean, so one of the things that it is there in the specification that if you have a very low powered serverless instance, like a minimum of 0.5, then maybe you don't have enough CPU for all these replicas
that's true.
to update data which is coming to this replication. So your replication lag can be a bit higher, okay? Instead of like 0.10 milliseconds, it can be probably like 0.5 or something, but who cares? It's just perfect. Okay, so.
But actually, you say something really, really interesting. I never thought about that given that you don't think too much about the capacity. I mean, having 3 replica that use 10% or use 3 ACU each, or having one that use 9 is the same in terms of cost, more or less. I mean, I'm now approximating a bit. It's not anymore as having 3 replica that are 4 extra large each or whatever. You can really separate the reader to do very different.
Yes.
That's really
so one reader is $43 a month.
Yeah,
so if you have a really complicated tenant, really complicated service, separated, like especially like pixel perfect reports or stuff like that.
Yeah, I was thinking KPI reporting and those kind of things.
Yes. Just $40, and these things are just, they will sleep most of the time, and then when it's necessary, they can scale up. And the good thing is when you think about this, these things are done occasionally, so you don't keep data for them. So you don't need to have a hot buffer full of data to execute these reports. It's fine for you to get this data from disk when you do that at once a month or something, or once a week or on daily basis. So if you do that really often, then you need to think about memory and how it's going to affect you. Because you pay for every single request to the database, so you have to think about that. So when you look at these things now that we talked about, it's a more provisioned world coming to serverless. So what's missing is some data layer that could be exposed via HTTP, like a data API, but also like scaling to zero. And these two things, when you look at the documentation, in both cases, they say currently not possible. So that means that these things are coming, But I'm not really sure about data API because they don't really do anything about that. And I don't have lists, publicly, okay? So they released data API as an open source package, so you can install it by yourself and do something. But really, you didn't see any kind of development. And sometimes I have a feeling that when I ask about data API, they don't see it as a priority. So it's just because not that many people in serverless world use relational databases.
And the way you use it might be very different. You might use RDS proxy and do something else. You might not need it.
So one good thing is that Serverless V2 now supports RDS proxy. So anything that was available in a provisioned Aurora, it's now available for V2. So if you use Lambdas, you have to use RDS proxy, especially with this especially with V2. Okay, so one of the things that I've noticed is that you have to with the provisioned server, it was really the number of connections, maximum number of connections, was defined by capacity of the server. So everyone has to be very careful now, because when you define the maximum capacity for serverless V2, you actually define the maximum number of connections.
You can have.
Okay.
Yes.
There is now a problem with Postgre. So if you set your minimum ACU to 0.5, you will get a maximum of 2,000, whatever you do. So just be careful.
No, it's actually a good point, that one, because I faced that one a couple of times. We tend to think like, of course, on the Aurora serverless, you don't really change much of the configuration. It's not like Aurora that you go in, or RDS where you say, okay, I'm going to change the max connection value. So if that is a parameter that depends on the memory, the moment you say that's the maximum ACU, you're basically defining maximum memory and the maximum value. And that's usually not a big problem if you don't use pools. If you have pools that open connection and you say, I want to keep 100 connection open at any time on every node or whatever, even just idle, well, you might run out of connection.
Yes. Especially with Lambdas. I mean, if you just if you just start opening connections, you are done very, very soon. But it's still like a huge number of 2,000 connections.
Can be done.
It's a lot. So if you have too many, if you have more than 2,000, then maybe you have another problem there.
Yeah, that's right.
So there is a thing to think about. There are some parameters in the server in V2 that can be set online, but some of the parameters need to you need to restart the serverless. You need to restart the serverless server, non-serverless, whatever, you know. So what's the restart? Okay, so the if you change the capacity of maximum capacity in ACUs in order for number of maximum number of connections to be affected, you need to restart it. So it won't change automatically. So yeah, and also some things are defined by formula, but formula doesn't is applied only during the restart. Okay, so you have to think about that. So a couple of things, but anyway, like it's something that you just don't think about. You know, why would I restart the serverless server or whatever? Okay, so if we look at the again on these charts, you can see that CPU is scaling, memory is scaling, but the storage is the same. It's the same thing. So the good thing is that whatever you do with Aurora being serverless and provisioned, you use the same storage. Okay, so all the benefits are there. That means that the global database is also there. So you can scale globally and have read instance somewhere waiting for something to happen. Okay, that's a good thing.
That's interesting, really.
Yeah, that's a great. I mean, if something happens, it will just scale automatically, and you'll get what you need. Okay, the problem is that you cannot scale horizontally at the same time. You can scale out up. But you need
that's one of the big topic as well about if it's really a serverless database.
Exactly.
I'm pretty sure the one coming from the more the Vitess world or whatever, that you're coming from the concept of I want to have some kind of sharding happening or whatever. You might even say that this one doesn't really scale. It scales to up to a point, but maybe that up to a point is good enough for most deployment. Probably is what most people need.
Yes. But you cannot have like super smart scenarios, okay, like a shard per tenant,
no,
or something that would just have like hundreds of readers or something.
Well, you can probably build it yourself on top of it, but then you're building yourself a technology on top
again. Okay, so this V2 specifically doesn't support horizontal adding more readers automatically. You know, it doesn't support it.
Yeah.
So, you know, you still need to think about what kind of configuration you need. Like, what is my noisiest tenant? You need to set that tenant to be on a separate serverless server. Okay. So yeah, I mean, there is a lot of work for AWS to be done. So when you compare this serverless database to DynamoDB, so how do you feel like about this? So how far is this from Dynamo to be called serverless?
Good point.
Millions of years, or just what do we have to do for developers to be happy? Okay.
Well, to call it serverless, we just have to change one more time the definition. As long as you keep changing it and say something different in terms of what serverless is. But I think is the natural point is, I think when you say we are coming from a provision world, that V2 is addressing more the provision world that wants to have something elastic. In some sense, even the entire serverless, even V1 is, I want to have a relational database and I want to have MySQL, I want to have Postgres because I need it, because that's what I know, because that's what my company is using, because I need certain features that they have, because the knowledge of the team I have inside the company has that knowledge. I don't want to rebuild from scratch to use the latest cool database from AWS, or I can use a mix. I mean, I know that Amazon is pushing a lot to have all of them together, but I mean, of course, it's easier to in that sense, in terms of being elastic, at least. Dynamo is much more mature than.
Yeah, it's really automatic. You know, you don't have to think about horizontal scaling or if it's too hot for some partition, then it will just magically fix everything. But the thing is that they're using MySQL behind the scenes. So I mean, sorry, InnoDB, okay, or something. So I mean, they were at least they were using it at the
originally
beginning.
designing.
Yeah, yes, exactly. So I mean, who knows what's there now?
It's pretty hard to compare. I mean, you could go hours to, because as well, like one key point for me is I want to be able to get out of Amazon, whatever reason. If you are on Aurora and you have a public IP address and MySQL, well, it's not easy. You might pay a lot of data traffic. It might be hard because your company got lazy and it doesn't have that strong knowledge of accessing the data layer anymore because the data is on the storage, but you can still do it. Dynamo, another option, you're getting much more coupled with the cloud provider. So I mean, there are 10,000 reasons.
Who cares, man? I mean, we have like billions of lines of code in the AWS. We cannot get out. You know, like I even got a T-shirt, so I cannot get out. So that's almost impossible. But when you talk about Dynamo, like the things that definitely not there, like you cannot really provision a single table in a relational database in AWS through infrastructure as a code. And that makes building simple applications really hard. You need to think about you always think about the relational database as a monolith server that will serve multiple microservices or APIs. So it's not just like when you design in Dynamo, you always design one or maybe two tables, couple of tables together in one single API or something. Here, you're like you are forced to spend less money to keep things together, like in a single database. So then you're in a problem. So that's. But how do you feel about how does Aurora Serverless V2 compares to PlanetScale or Spanner or something? In PlanetScale, you pay for query that you use.
That's a very good point. I read many comments as well in the last few days of people that are saying, I don't want to pay for CPU. I don't want to pay ACU, basically. I want to pay for the query that I perform. I don't want to think too much what they represent. And I think it's a fair point. I mean, if you think really on a serverless world, you would like to think, oh, I want to pay. It gets as well harder to estimate because it's as well, I mean, it's already hard. If you think about the most simple scenario, I have a database running on, let's say, RDS, even already outside Amazon. I know how much I pay for that one. The moment already you move to Aurora, it's not that straightforward to figure out how much you're going to pay for read and write and whatever. You have to do some numbers.
Yeah.
So when you go on the serverless world, say then how much you will pay will be pretty hard to compare. But I get the point. I like that concept.
Yeah. But look, what do you like more? To pay fixed price and do whatever you like any kind of query, or to be charged like you charged with the Dynamo per RCU and
ideally, I mean, in the optimized world, I would like to be charged for what I use, and that's ideal.
But if you have if you have bad indexes or
that's the point. The good thing about the prefix price is easier to forecast and I can control it. You might argue that missing index means that in one case you're able still to scale, you just pay a lot, and then you can put the upper limit on the maximum CPU you want to use. On the other case, your own scenario managed by yourself, you most likely are going to fail.
Yeah. In most cases, SQL developers are fine if their query runs slower because there's not enough capacity, but it will occasionally run slower. Okay, so it's
probably
just
true. But I think the hardest part is if you are not really strong, and no one I think is really strong in forecasting the cost. The more you get to the granularity of per request, per number of kilobyte of the request you then define what is a request. Well, a request is probably, I don't know, I throw some number 1K in a read, but is 2 per every write plus whatever else. It gets really, I mean, it's cool. Maybe you can optimize better, but it's pretty hard to forecast. And I think many people find that out.
So what we see now, like some serverless developers like complaining about Aurora, it's mostly coming from their experience with the Dynamo, and they would like relational databases to be like Dynamo, but then this is more, this looks like more this, let's bring the world of provision capacity and servers, let's bring it closer to serverless and closer to these technologies that need to scale, but it won't be the same, you know, you want, but then look at the Google, they have Google Spanner, and then what is that? Why AWS cannot build something like Google Spanner?
Maybe it doesn't want to. I don't know.
Yeah, maybe it doesn't want to. Maybe they get more money, because if you look at the pricing here, this is huge when you, and then look at this. If you can get 70% on reserved instances.
Yeah, that's what I was thinking, that you haven't really even considered that you can on a 3 years reserve.
Yeah. Maybe not, maybe 65%, and then. So what then? I mean, we cannot. There's no way to get this price for serverless V2 lower by paying anything in advance. There's no such a thing.
There's no such a thing yet. There's nothing yet in the saving plans. Maybe there will. I have no idea.
Yeah.
But personally, I like this pricing model more with the per ECU, because it's easier to compare through V1 and V2. I mean, the number you have there makes quite a lot of sense, and the difference is huge. So, I mean, reality is, if you have a steady workflow on Aurora that is very predictable and goes, and you don't expect big changes, you you for sure are going to pay less if you stay provisioned. I mean, so my feeling is not everyone has to go to serverless. But you can probably, from getting some metric on your average CPU in the last 2 weeks or whatever, with your daily peaks or weekly peaks or whatever, have a feeling how much more you will pay going from Aurora to Aurora Serverless. Then I think there's still an overhead. It might even be okay, because at the end, maybe, I'm not saying I'm throwing a random number. Let's say that I have to pay 10% more to go serverless, but I have the benefit that if I have a last deployment, get a query that is not really terrible, but a bit worse than before, my capacity is there. That's already a benefit. So I am happy to pay for it. Don't have to manage myself the size is a benefit. And as well, often maybe it's 10% of the CPU cost. But you mentioned as well before, then as well the data, the storage, the backup, and everything else. And maybe on the overall deployment, that extra cost is not anymore 20% extra, it's 3% extra or 5% extra. And maybe I'm happy with it. I'm okay in paying a bit more to have that feature. I think that's a bit.
I think that people should start, if you have your own cluster now running already, you should add one.
Try. Yeah,
give it a try. Add one serverless instance. It won't cost you a lot, like $40 a month. But then you need to redirect some traffic to it, okay? By defining, and you define one endpoint that will end only to that instance, okay? So, or maybe a group of serverless stuff. So then you'll see how it works. So at the moment, I'm pretty amazed how quick it is. It's just it's amazing that in a second it can scale up so big, and that opens a lot of possibilities if you have spiky workloads. If you have flat lines, doesn't really make sense. That's it.
It's nice to play, but you need spiky workloads. Yes. And as well, I think as well a lot not predictable one often. It's good as well. I mean, because if you're spiky but very kind of, I don't know, like I always think about shopping center or things that you know that at lunchtime and evening you have a bit more traffic. Well, you can do that with read replica and handle it through the day. But if you have really spiky or really unpredictable load, probably very cool.
Yes. So a couple of things that I've noticed that may influence people. So maybe just to think about that. So the first thing is you can only set capacity for a cluster, like minimum and maximum per cluster. You cannot say
per node.
not per node. So every node has to have the same one. Like if it's 0.5 minimum and 64 maximum, that's it for all the instances. And you cannot cap it or just make it minimum or something. The other thing that was that I didn't learn, I didn't really read all the specification the first moment I started it, so I didn't realize that there is the big difference now in tier 0, tier 1, and other tiers. So what is a tier? So when you define servers, you put them in some tier, and that tier was like from 0 to 15 or something. And previously it didn't really mean too much. Like if you it was just the order in which some reader would be promoted to a writer if something happens, you know. But now there is a big difference. Servers in 0 and first and 0 in 0 and number 1 tier, they scale together. So if you have a writer and then you put a reader, serverless reader, in the same tier, so whatever happens with the writer, it will scale up the same. So even if you put like 2 serverless instances, they will scale up and down together. Just for the case that when something happens with the writer, you will
get promoted. Yeah.
You will have the reader with the same capacity ready for that. So that means that AWS doesn't have an infinite capacity. So if you don't have resources at that moment,
you might run out of of nice Graviton processors.
Exactly. That happened to me, the same thing, like especially in some AZs, like in Ireland or that we're using, these things happen. So you need to be careful about this, because
good advice.
If you don't put the thing that you set the maximum ACU doesn't really mean that you will get it when you need it immediately. So it's probably something that AWS is like investing a lot, but you cannot promise everything. So it's impossible to pay for 0.5 and then you get
64,
always on 64 ACUs. So that's something to really think about. So one of the things that also people are complaining that there is no the system is not pausing after inactivity. But since this is provisioned server, provisioned cluster, you can always stop it.
Yes.
Stop means that you can have it off for 7 days. You don't pay for anything except storage. Yes. Yeah. So if you're using it in production, in development or staging, you can always stop it by API and then just run it again, and then it will start in a couple of minutes. But it doesn't really matter. I mean, if it's something like development or staging, that will be fine. So something to think about. And also from you can migrate from V1 to V2.
I didn't know that. I didn't check it.
If you create a snapshot, but there's no other way. You know, you cannot add a reader or something because that's not available in V1. So you can do a snapshot and then start it in again in a V2, but that process is also very, very complicated because V2 requires the latest possible version of MySQL and latest possible version of Postgre. So you need to have both upgraded. So So you need to upgrade step by step to that point. You know, so only MySQL 8 and Postgre 13 are available. And it's not easy to jump into to some of these.
Good advice.
Yeah, it was almost impossible for me to jump from 5.7 to 8 because I had backtrack enabled in past. So if you have backtrack enabled, you cannot just do the upgrade in place upgrade. So that's it, and you're done. So backtrack is like a cool functionality, but then really, I mean, I can't upgrade because of some. Don't use it if it's. So so one of the things that will affect the scaling are sometimes very, very simple, and you will know that because you have more queries, more usage. But then AWS says that it can scale server by itself to do some job, like to do some maintenance stuff, upgrades or something. So you will pay for something that AWS does. Okay.
That's part of it.
Oh, so yeah, that doesn't happen in Dynamo, I would say, or something like
we are still seeing this one as instead it's not really, it's a serverless concept running on a server. There's still, at any given time, there is one server running.
They should be able to bill per something which is smaller than CPU. They should get deeper. I want to tag my queries so I can know which tenant is using that much IO or something. I want to be aware like that this is AWS doing, or this user of my database or something. So we need to get more fine grade pricing, or at least billing, so we can get into more details of who spent something, or why is it using, which service is using more ACUs than others. It's hard, but still, something that we need to think about. So one of the things is also network throughput. So you have to be very careful, that it's there, what network. Well, okay, between what, so sometimes you have like more traffic to do some queries that will bring something from the database, or maybe something that you will send to the database, like a large set of data to be inserted, or stuff like that can make like a higher load and start a higher CPU. So well, when you look at all these things so far with the V2, how do you feel about that? So are you happy, or are you going to use it a lot?
I just still don't know. I'm quite happy. I mean, I'm quite happy that it's finally public and we can play with it. It's an exciting step forward, and I like the idea to have less bits to configure. I think it's still less than 1 week after SGA, a bit too early to really say how much is going to. So as well, for example, on the cost side, it really depends at the end. At the end, we tend to discard a bit too much how much is the difference in price, but at the end, you really need to try your own use case and see how much is going to change and how much is going to affect it, if it's worth. So I mean, I don't buy the AWS advertisement that you can save up to 90%. Well, yes, of course. If the idle database running, you can save even 100. But
yeah. Exactly.
But that's would there be customers that are going to save a lot of money? Absolutely. There are going to be customers that are going to pay more. Probably yes.
But this is far better than Serverless V1, despite the fact that it doesn't have data API or
yes. For people definitely coming from RDS first, then Aurora, I definitely think that is the next step forward. I mean, it's giving you what you had, more or less, plus something else. Before you were getting something different. I wouldn't say it was a toy, but if you had a large cluster on Aurora running with a provision, multiple read replica and so on, would you consider V1? No, because it didn't have most of the feature you needed. It was not, as you mentioned, it's not multi-Z. Yes, he had the data API was getting to 0, but it's entirely irrelevant if you're running Aurora. So I think many will move, but let's see. I'm curious. I'm really curious.
Yeah. So this is like a typical AWS service. We get something and we are kind of super excited, but on the other side, so many questions, so many complaints. And yeah, that's why what AWS heroes are there for, to complain and
just to try, test it.
Yeah. But the good thing is that the team is very open in terms of like
absolutely
how it works and stuff like that. But in terms of like what's going to happen next, they don't say anything.
Of course.
So that's something, to think about. What the future will bring to us. Thanks, Renato. I mean,
thank you.
Yeah, that's you're going to London Summit now?
Yes, tomorrow morning. Tomorrow early morning, I'm flying to London, attending the summit.
Have a nice time there, and see you again soon.
See you hopefully in June.
Bye-bye.
Ciao.
Ciao.